So we're going to do 34 here, and I'll kind of show you how we're going to do it. So 2 is basically being multiplied by ln of x. So remember that the power property will allow me to do what?
Bring it out to the front.
Yes, let me pull it back up. Okay. And for some reason it takes a second to let this work. Okay, so I would start by bringing this 2 up here as a power. So this is gone. And then I notice it's just ln of x squared and then minus 2. So I could add 2 to both sides. So I end up with ln of x squared is equal to 2. And remember that the base for ln is just e. So it ends up being e squared is equal to x squared. Therefore, you can see that e is what? Or x is what?
E.
Just e.
I thought it was like ln of x minus 2, not ln of
Okay.
x.
I'm glad you brought that up because that is a very different problem. That problem, how would I do it? I would go right in and rewrite it as an exponential with my base of e. So it'd be e to the 0 is equal to x minus 2. E to the 0 is 1. Add
X
2.
minus 2 squared.
No. If you do it, is there a 2 out front?
Yeah, there's a
still?
2 out front.
So then I would do 2 here. Well, you know what? I couldn't rewrite it. What I have to do is start, I forgot about the 2 out front, but it's not going to change the answer because I'd start by dividing both sides by 2. So I still have 0 here, and then this side is divided by 2. So I have ln of x minus 2, and then I would say e to the 0 is x minus 2. So I'd add 2, and I get x is a 3. Is that what you got?
Yeah, I got x.
Okay, so you just misinterpreted the problem, but you did the wrong problem but the right way. So good. All right, so tell me another one.
You said 35? 35 was.
And the reason I
How'd they write it though?
Okay, wait, one question at a time. Let's finish this one before we move on.
35.
Dalton, you approach my
so it can't be like a negative e because you can't take the log of the negative, but you're also squaring. So.
Where are you seeing a negative? Where are you saying that?
Like, so whenever you take the square root of like e squared equals x squared, why isn't x equal plus or minus?
Are you talking about right here?
Mm-hmm.
I didn't ever take the square root of anything. I took a base of e right here. So base of e, and I rewrote it as e squared. E squared is equal to x squared. So I ended up with this little equation. And then from that, I'm not actually doing any math other than recognizing that I have some value e to the second power is equal to x to the same second power. So then the bases must be equal. So e must be equal to x.
So, but like, wouldn't it also work if like the e was negative, like a negative e squared?
Well, if that was the case, no, because then my base would be negative e, and that's not.
But like.
Well, you're changing the problem, but I don't know how you intended the problem to originally look.
Okay.
So, could I do this? Is that what you're asking?
Yes.
I could do that, and then are you saying then x would be a negative e?
Like a plus or minus e, because like to solve for that, somebody like take the square root of both
No,
sides.
same thing. I'm just recognizing that I have an equality, and because I have the same power, I know my bases must be exactly the same. Now, I would also need to make sure that in the original problem that a negative value will work. You always have to go back. If you're doing a log problem, if you're like evaluating it, solving it, simplifying it, that kind of thing. So I don't know if I answered your question because I don't know what the original problem would look like for that to actually have happened. But I think your thinking is right. It's just we'll have to find another problem kind of like that. Okay, so somebody said 35 maybe?
Yeah.
Okay, so for 35, I could pull the 4 up.
Wait, that's the same thing. It's all that's before.
Yeah, and then this is gone.
So it'll be 1.
So I end up with
Divide
ln.
1.
You gotta divide it.
Zero, right?
No, it's just ln1
Oh,
equals
it's
0.
1 because x over 4, x over 4 is.
ln1 equals 0.
So I can do it that way, or could I also do it this way? ln of x to the 4, add this to both sides, is equal to ln x to the 4.
Did you just divide them?
And then you divide by ln.
X equals anything greater than 0.
No. And then x.
What is the answer for 35? What did it say?
Greater, X equals greater than 0.
So basically, it's all real. Y'all see I have the same exact thing on the left side as I do the right side?
So it's all real.
So any x will work as long as x is positive. That's what the answer is saying. Any x will work such that it is greater than 0. So this would be the answer.
Wait, so is that
So it's not really a domain per se, it's the solution set is all x's greater than 0.
Why does that say X equals?
Because x, this is just a notation when it's a solution set. You could also write it 0 to infinity, like this. And then this, would this be inclusive?
No.
No, very good. It has to be greater than 0 to take the log of it. Okay, so that's a really good one. I'm glad you asked about that one. 25. Let's look at 25. Okay, guys, so here's 25. And so what I'm going to do with this, I'm going to kind of set it up for you without the calculator all the way down to like the last step and show you how easy it is to do in the calculator at that point. So I have a Newton's law of cooling problem, and it's the formula that we've looked at before, but we haven't really done much with it. So I need to plug everything in, and I want to know how long it takes for the coffee to reach its best temperature, which is what? 140. So I want to know how long it's going to take for the ending temperature to be 140. My surrounding temperature is 70. And then the difference between the initial temperature for the coffee, which is 206, minus the surrounding temperature of 70. And then I have e to the negative kt. Do I have either of these k or t values? Yes. I have what?
Okay.
I have k is 0.283, and then I'm going to actually be solving for t.
When are we gonna do the deadline thing?
That will be like later next week, like Thursday or Friday.
Miss Morgan so.
Okay, so how do I solve this big mess of numbers?
Subtract 70 first. Subtract 70 and then solve the thing. And you get 7.
Okay, very good. So subtract 70. So when I do that, I end up with 70 on the left side. So if my pen will follow me. Okay, I'll write it over here. So I have 70, and I don't really need the degrees. I'll put that back in at the end. Is equal to what?
136.
E to the negative 0.283t.
Okay, let's divide 136.
Very good. And I'm not actually going to do the division yet. So this will go away. And now I'll take the natural log of both sides. So I get ln on the left side. It's 70 over 136 is equal to, remember, all this is going to come down front in front of what? ln of e, which is just 1. So 0.283t ln of e, which is just the number 1, and then I'm going to divide by negative 0.283. Divide by negative
Is that a full
0.283.
answer?
That's the answer. So this is the answer in exact form. The time that it will take will be ln of 70 over 136 divided by negative 0.283. Now you just do that in your calculator.
I did that.
Will we ever be given something like that? Be
It was
asked
like
to solve for, like, the
2.34
starting temperature? Or like the
Yes, you could
temperature
be. You could be. Let me wrap up this though. On the quiz and on the test, you're going to be asked to leave your answer in exact form. That is exact form. So I'm going to want to see that before you plug it into your calculator. So that's why every time I've been taking you all the way to the end without the calculator. And then in the calculator, this would be pretty simple. I would just do ln, so ln of 70 divided by 136. I get that value, and then I would divide by negative 0.283. And y'all, this is as precise of an answer as you can get.
We're recording right now?
Yes.
Where?
Where? All right.
Can they hear us? Hi,
Yes,
people.
they can.
Hi, America.
Okay, y'all are making your grand debut. Okay, tell me another one.
Oh, that's good.
30, okay.
Miss Morgan has us trapped.
Where is it? You're putting on the recording?
Okay, 30. Okay, so this is basically like a PERT problem. It's the exact same equation that we had used like yesterday in the paleontology example. Remember that? The only difference is here K is positive because it's a growth. If K is negative, it's a decay type of problem. So what I'm going to do is read everything. The George River herd of caribou in Canada was estimated to be at this amount, 4,700, and grew at an exponential rate to 472,000 in 1984. So how many years have gone by?
What's the difference between that? Oh wait, 30.
30. And then this is going to be what? Our ending amount. So this will be basically our ending amount, we can just call it N. Well, we'll call it P, sorry. P of T. And then this is going to be what? P sub naught, P, the starting amount, the initial amount. Okay, and then E, and then do I know K or T? I know T is 30. So let's just set this up and solve for it. So I end with 472,000. I start with 4,700. It is growing pretty quickly, isn't it? Wow. Then I have E. I do not know my K value, but I do know my T value is 30. So it's 30K.
Okay, so we
Isn't it
divide by
negative?
4, so
Oh,
it's
it's
0, 0.
PERT,
Then
yes.
we take the natural log, and then we bring down 30K, and then we solve for that.
Yes, I'm going to show you all the way to the end. So this is gone to 4,700 divided by 4,700 is just 1. And now I'll take the natural log of this on the left, and of course I take the natural log over here. So the 30K
It just comes down.
comes down front. So this is gone.
Everything's gone.
This is 1 divided by 30. So K is exactly
That.
this. K is exactly that value.
Okay, I like this.
So you would do it in the calculator, and you would basically just do ln of 472,000. Be careful, it is not divided by the ln of 4,700. It's the ln of the whole thing. Y'all be careful with that. And then I would divide by what? Next. 30. It was 30, right, thank you. Now this is going to be my growth rate, if I can get my little thing to work.
This is how 10 now got the
Oh, it went dead.
maths.
Why does it always die?
I don't know, because I use it a lot. So you would just divide by 30 and you get the answer there.
How did you get 30?
30 was the exponent
It was the difference between the two
your K value. Yeah, because 1984 minus 1954. All right, so did that help? I think Caroline, you asked that question. Okay, guys, that is basically what we did yesterday for the paleontology example. It was more confusing to you yesterday probably because it was new to you. But there are many times you would then take that K value, and for example with the caribou example, I could say if there were 3 million caribou in 2000, how many would you have in 2010? Would you be able to find that? You know the growth rate, so then you would just plug in the time of 10 and solve for that. So you can use that to build basically a function that can be used over and over.